Physics Challenge 3, Alternate Current. Now we have a coil, turn number is 1050 centimeters long and 3 centimeters radius. So we can get the inductance L, and capacitance is the 0.2 microfarad. Find the inductance first and find the resonance frequency. Now these are connected in parallel, so L and C are connected in parallel. Let me show you how to get the resonance frequency. First of all, we have this in the textbook, this straightforward. Just inductance is mu 0 is 10 to the minus 7 and 3 square times pi 0.03 square that area, right? Okay, so divide by length. 0.5 meter, right? So that's pretty big inductance. I used a calculator earlier. It came up with 0.0071, something like that. Okay, so once we get the inductance, how do we get the resonance frequency? When they are connected in parallel, okay, impedance is this format, and we take a derivative by frequency and find this part. But actually we take a reluctance, this 1 over z equals j omega c plus j omega L and over c. Okay, and we take the derivative. That's much easier. So d omega minus z equals jl plus minus j omega second c1. We find a point that becomes 0. Okay, so omega becomes square root LC, 1 over square root of LC, and omega is 2 pi f. So frequency is actually 2 pi. Okay, so we plug in the L. L is something like 0.0071 or something. C is 0.2. And you plug in this number, you can calculate. I think it's 4 point some kilohertz or something. The max or main impedance, and the reciprocal number of impedance is reactance. Okay, so when impedance is maximum, reactance is minimum, and either way it's okay to define resonance frequency. The reactance is a reciprocal number of impedance. Now, the why resonance frequency is important. Okay, here's a reason why. Okay, suppose you have R here and provide a volt, and this volt, the source of the voltage, has frequency domain. I hope you learned the Fourier analysis. There are many things, but has a spike noise here. Okay, and you want to remove this, so it's a filter. It's work as a filter, because what's happened is the voltage here, because of this, the voltage is going to have a maximum voltage. That means has a minimum voltage here. Okay, so if you take output voltage here, then it's going to be like this. So this frequency area is going to be damped. It's get less. So you can remove this noise. So that's called a notch filter. Okay. Now, if you do the same thing with say current input source, then you can get the reverse filter like this, and that means only this frequency you can get out as a current source. These two nodes provide a current. Okay, so it's a filter. Another important application is like oscillator. You have a crystal. Crystal is basically capacitor, right? These dielectric materials, the widths change around. When the width get small, capacitor is big, so C value change around, and you give a feedback, right? So what happened is, without this filtering, the wave could be very ugly wave. Now with the filtering, you get clean sine wave because you extract only targeted frequency. Okay, so that's what the resonance frequency is about. I hope you enjoyed this video. Please check other video too, and if you like, subscribe.